So for our first exercise, we're going to go to a web browser, and we want it to have the BioModels database available.
Okay, so Google, I guess. Search for
any search engine will do. BioModels. BioModels database, BioModels DB, BioModels EBI. Many things that might work. And in this case, with BioModels database, it should inevitably come up under the first hits at Google and also Bing and other search engines.
Yeah, so the web address is ebi.ac.uk/biomodels. I can click on it from here, of course. Okay, let's make that a little bigger. I think we can have a bit more.
Okay, so first thing might be a few words about the BioModels database. So it has turned out into one of the most valuable resources when it comes to biological modeling and when it comes to sharing knowledge that has been generated through working out a model in expert groups that are composed of mathematicians, engineers, physicists, and other computer proficient people. So it has been a desire since about 20 years to get away from the old model of having a specialist programmer submit something that they have written in some sort of private code, submit not the model, but actually a description of the model only. And it was a very hard time in the early days of what is now called systems biology to actually reproduce somebody else's model, because there were inevitable things that were not reported in the published paper, because there were shortcuts, there was mathematical annotation, and it was not clear how that actually translated into code. So these things have changed. You have no worries about this. This is now transparent. And one of the major results of this is the BioModels database. It is hosted by the EBI in Hingston near Cambridge. Also other institutions like Babraham, UCLA, and so on involved in this. And so what we have here is not only a collection of models, but it's actually a proper database, an annotated and searchable database with meta information such that all the things that you expect from a proper database of experimental data is now also available when it comes to models. The first thing that needed to be done was to put all this in a standard framework. So all models had to be compatible and machine readable. So for this purpose, the so-called systems biology markup language was used. And the models provided here are in this format, and this agreed upon format, where we can actually exchange it among almost any platforms these days and execute it from different platforms.
So that's the file format that we're going to be using today. Sometimes they come with an extension .xml.
Yes,
right?
This is what we're going to see today.
And sometimes maybe with .sbml.
.sbml is another option, but typically these days platforms like SimBiology, like MATLAB, like Copasi, and they all have the possibility to include all of these formats as long as they agree to some markup language standard. Right. If we take a look at the BioModels web page, what we can see that they have not only a couple of hundred models, but they have many hundreds. They have 112,000 metabolic models, then 27,000 non-metabolic models mentioned at the bottom of the page. However, this is something where we have to be very careful. This is just a recent explosion in model generation, namely producing models automatically, to having actually a computer script that takes information for some network database and converts it into an executable model that is able to perform dynamical simulations of that model. So we're not going to look into these because we're going to be restricted to a subset at the center of the page where it says 575 models, namely those that are manually curated. Means one of the big values is here there's a set of experts at EBI who actually take every submission that's being made privately in the background, take it and look at it and have it run and standardize it such that when it comes to the front and visible to us as a public, it becomes a model that actually runs the way that we download it. It's actually executable and it runs. It produces typically a figure from a published peer-reviewed research article.
Okay.
So that's what we want to do as a first case. If you have a look at the BioModels database, there's a lot of information surrounding biological modeling, which you might find valuable because this has been set up not so much for the expert modeler, for the mathematically or computationally trained people, it's actually meant for the users, for us biologically trained people who are the clients of such a repository. And I might guide you if you are just interested in having a quick read. On the right-hand side, above the news is the model of the month. If you look at the previous models at the bottom, it says access this model. This somewhere there's a code of all the previous models where you have just something picked out for you, described. You have an introduction of what is there. You have the data on which it is based. You have, of course, also the links to the papers, to the original papers, to the current model, and to different versions of the model, and any follow-up work that has been done on it after submission. So if you want, you can just take a look at it. If you look at previous entries, you might find a model in your field of interest. Maybe that increases your motivation to look a bit deeper into the modeling process. So what we are going to do is we're using the search field on the top right of this web page. There's a search field which is quite convenient now because it can take all sorts of inputs.
Okay.
It used to be that this needed very specific accession codes or identifiers that come either from the BioModels database or related, say, protein database Europe and such things. It's now also searchable with just text input, and that's what we are going to do. So if you have worked previously to this session through the materials for this session, we saw that this was concerned with the model of glycolysis. And this is what we are going to look for first. So the first author of that paper that's mentioned is a guy called Nielsen, a Danish PhD student at that time. And so let's just make a search for this first name.
Nielsen.
Lsen.
Okay.
And just make a search because it's not that much of a common name, so we can try to have a search there. And you can see, unsurprisingly, the model that has the name Nielsen in the name is first choice.
Okay.
So it gives you a number of secondary options under the red bar, which are the non-curated ones, means models that have been submitted and have been found fit for public use, but have not been looked at individually by an expert at EPI, whereas the ones under the green bar are the two that are manually curated, and you can see that the first one, Nielsen 1998, is the one that we are looking for. It has the extension glycolysis, so that's what we want. Now, in order to access these models, we now need to go to click on the BioModels database identifier for this model. It's actually number 42, and you can recognize the ID by its prefix, which is BioMD. So these are all the IDs that are given to entries in the BioModel database. So BioMD, and with the last number 42, so it was one of the early submissions to this model. Just click on it, and you'll get an option of downloadable forms of that model. And we find that on a menu where it says download SBML. So SBML is the Systems Biology Markup Language, and it gives you several versions of the model that we can use for download. But of course, we don't want anything auto-generated that has not been checked. We want the one that is called curated.
So this is just underneath at the top of the page where it says the name of the big identifier in the name. Right below it, there's a download SBML button. And
in that menu, you want to select the curated one. It's called L2V4, so version 4.
Okay, I'm just going to click on that.
And if you click on it, your browser should automatically start to download this model.
If it doesn't, if you get the raw code, go back to this page, right click and select save link as or similar.
Yeah, so right clicking on that menu will give you the option also to download it to your desktop or wherever you want to have it.
So this page looks like it's got lots of interesting information about the model as well.
Even if we don't go any further, just looking at the tabs that are associated with this model, if you just click on the one that's overview, so apart from having the information of who submitted it in the paper where it was, all the details of the model actually can be found here as well. So this is not very informative if you haven't read the paper, but once you have read and understood the paper, here are all the things that are needed, namely all the reactions, all the metabolites that are going to be simulated, and so on. There's a part that's called math in the next tab. If you take a look at this here, so these are the instructions on how the metabolites interact such that they form a network. Which means that if you look under reaction 1, for example, it tells you, yes.
So I can click the little plus to the left of the name of the reaction and it gives me more detail.
It gives you an expansion of this. It gives you actually all necessary background information about that specific reaction. And at the top of this, it gives you the way in which it is entered into the modeling process. So first as a reaction scheme above the mathematical formula, and then below that where it says compartment is the formula that is then implemented somewhere in the code, about which we don't worry at this moment. Okay. There's some further thing if we go to the last but one called parameters. You can see that actually numerical values of all the parameters, all the initial conditions of metabolites are here, because you know that once we want to do a simulation, we need to give it proper numbers. We can't just say this is a qualitative scheme or something. We need to have proper numbers on which to operate. So while we're going to look into this much further in upcoming modules, suffice it to say that you have access to all of this just with a click on one of these tabs here. All right.
Okay.
I think that concludes what we can say about biomodels. Let's close this and let's go and get this thing into MATLAB.